Hello. Today we're going to solve the problem in LeetCode.com. That is construct a binary tree from preorder and Inorder traversal. Let's read the problem. Given preorder and Inorder traversal of a tree, construct a binary tree. Note, you may assume that the duplicates do not exist in the tree. For example, given preorder 3, 9, 20, 15, 7, Inorder 9, 3, 15, 20, 7, return the following binary tree. So this problem asks you to build the tree data structure with the given preorder and the Inorder item sequence. So you have to come up with an idea how to construct a binary tree. First, we have to understand the characteristics of preorder and Inorder traverse. The left picture shows you the preorder sequence, and the right picture shows you the Inorder sequence of traverse. I didn't use the problem example. I just used a more straightforward example. The sequence is like this. Preorder takes the root node first, and then the left child and the right child. But Inorder takes the left child first, and the root node and the right child sequence. If you want to print the items of tree structure according to preorder and Inorder sequence, the pseudocode would be like this. Preorder function display the root first, and it calls the recursive function for its left child and for its right child. On the other hand, Inorder function first calls recursive function for its left child and print for its root node, and then lastly calls recursive function for its right child. This is a way of searching algorithm in preorder and Inorder respectively. So how can you construct a tree data structure using the preorder and Inorder sequence? It's described here with a basic concept. I just intuitively thought that tree data structure can be created using the preorder sequence easier than Inorder sequence because the root node first appeared in preorder sequence. Thereby, I can naturally build tree data structure recursively, like this pseudocode. But we have to know that the leaf node to return the recursive function of left child. That's the key idea of this problem to come up with. In the picture, we can see that the 4 is a leaf node. How can we detect the 4 node is a leaf node or not? At first, you can construct a build tree. At first, you can construct a binary tree iterating preorder sequence. 1, 2, 4, 3 nodes are created sequentially. We have to know that number 4 is a leaf node by matching the first item of Inorder sequence, and then we have to move the index of Inorder array to the next point, and we can know that the number 2 is already constructed in the tree. That means we have to up a tree level where we construct the next node. We can construct the number 5 as the right child of number 2. And we also know that number 5 is matched with 1 in Inorder array because after creating the right child, the recursive function is returned. But still, we have the matched number 5, so we have to move up 1 level and then move the index of Inorder array to the next point. And then we create a number 3 as the right child of number 1, and then 6 is created as the left child of number 3 without returning because the number 3 is not matched yet. We can see that the number 6 is matched. Before doing it, I forgot to explain the number 1 is matched. just after matching the number 5. That's the reason we had to move up to the number 1. And then the number 6 is matched, and also the number 3 is matched. So we move up to the number 3. And then lastly, we create a number 7 as the right child of number 3. This is the basic idea of my solution to construct a binary tree. Yeah, during we iterate the preorder sequence, we can have the matched element of 4, 5, 6, 7, and for every matched element, we iterate backward to check the more matched element, which would be the parent. I mean the first matched element during iteration would be the leaf node, and another matched element during the backward iteration, such as 1, 2, 3. That means we have to up-level by returning the recursive function to create the next element as child node. Let's see the code to build the tree data structure using the Inorder sequence and the preorder sequence. I declare the build function. Build function has the preorder and the inorder array and the root node pointer as a reference, and it also has the preorder index and the inorder index as a reference because the recursive function should share this value updated through the function call. Depth variable is just used for debugging to know the depth of recursive function call. The first line, create a tree node using preorder array by increasing preorder index. And second, compare the preorder element and inorder element values each other. If the value is not matched, it does the recursive function call for its left child to create a left child node, and it stores the return value in matched variable. It will be the backward matched count of elements. I already told you in the previous explanation of this algorithm, during the backward iteration, if we had the matched element, we have to return the function to up the current tree level for next operation. When returning, the matched count should be decreased by 1. Else part means the fourth match of element. That means that the matched element is leaf node, and then it calculates the backward matched count by using the for loop going backward to the 0 index and compare the preorder and inorder element, counting the matched count. If the matched count is more than 0, it returns the current function by decreasing the matched count 1. If it's not returned, it calls the build function recursively with its right child. It also returns the matched count, and if the matched count is over 0, it should immediately return the matched count. Here, we didn't decrease the match count, just return the value intact. The runtime of this code is 8 milliseconds, which is faster than 98.38% and less memory than 95.24%. This code is already high performative, but I try to optimize. I declare the hash map like this to store the traversal element of preorder array. The reason is that I wanted to avoid the for loop in brute force way to match the preorder and inorder element. So I use the hash map defined function to search for the traversal element of preorder array to match with the inorder array element. But the runtime performance is not changed, even though the memory usage is much increased than before. Thank you for watching. See you. Bye bye.